Conditionals. In this tutorial, I will assume you know what a variable is, how to write equations, and how to get inputs and provide outputs to the user. Conditionals are used when lines of code execute only when a certain condition has been met. So we can skip lines of code. So far, our codes have always been start at the top, end at the bottom, and execute every single line in between. But that is not always the case. For example, the quadratic equation is a simple problem: ax squared plus bx plus c equals 0. It's very easy to solve by calculating the discriminant. Delta equals b squared minus 4ac. But then we have to make a decision. Is the delta positive, negative, or equal to 0? This leads to 3 different sets of equations. If we had to develop a script to solve for the quadratic equation, we'd have to skip 2 of the 3 equation sets. So we can skip lines using conditionals. We wouldn't want to write 3 separate script files. Then we'd have to do the work of calculating discriminant outside of the code to figure out which code to use. That's not practical at all. We could put all the coding in one file and only run the part that we want. Once again, that is not practical. We'd have to decide what to do. Instead, we'll group the parts that are common to the problem, like getting A, B, and C. But when it comes time to calculate, we'll tell MATLAB to only go to specific lines. And if there are lines below that are common to the problem to conclude, then we'll take them out and put them at the bottom. There are 2 possible conditional statements in MATLAB, the if statement and the switch statement. The if can do everything. The switch might simplify the syntax a little bit, but we'll see this in another tutorial. The general syntax of an if statement includes 4 keywords: if, else, and end. Now they are in order, and not specific order, which means that if you type it in a script, they'll appear like this. They will also show up in blue. If, and then you will write a condition 1. Remember that conditions use relational operators, such as greater than, less than, maybe equal to. Those are the symbols that will go right there. Else if will be the second keyword, condition 2. Else will be the last keyword, and end will conclude the if statement. In between each of those keywords is where you want those lines of code that need or need not be executed. The 2 lines between if and else if represent where you can code 1 line, 2 lines, million lines of code. But this part will only execute when condition 1 is true. Between else if and else, you can again put 1 line of code, 2 lines of code, million lines of code. But that block of code will only execute if condition 2 is true. And it continues that way all the way up to the end keyword. Now there are very important key points of an if statement. It does not stop at the end. Just because MATLAB sees end does not mean MATLAB will stop. If there are lines of code below it, MATLAB will continue. Remember that MATLAB will always start on your first line of the script. But the goal for MATLAB is to reach the very bottom of your file. So although it sees the end keyword, a lot of students believe that that's where the code will end. But that's not true. This is where the if statement ends. But that's it. It's a little part of a bigger code. MATLAB will check in order. It will read from top to bottom as usual and check condition 1. If condition 1 is true, MATLAB will execute the lines that are in between the if and the else if. That's how MATLAB knows what to skip and what not to skip. Those keywords are crucial. If condition 1 is false, however, then MATLAB skips to else if and checks condition 2. If condition 2 is true, then MATLAB will execute whatever is between the else if and the else. Then it will skip to the END keyword and continue on with the code. So as you can see here, MATLAB would have skipped the first part between if and else if. Those lines would not have been executed. The very first condition that MATLAB finds true, it executes those lines. By mistake, we could have coded multiple conditions that are true, but MATLAB does not check every condition. It is important to remember that the very first one that is true will execute that portion of the code and skip to the END. MATLAB will not check further conditions. And it continues. So let's come back to our example. Right here, how many conditions do you see? There are 3. Delta can be positive, negative, or equal to 0. So let's go code. As usual, the algorithm is rather straightforward. Prompt for the givens, calculate the discriminant, and solve using the correct method. Notice, however, a good practice is not to write if statement. This is the worst comment you could do. What is the if statement going to do? Why is it there? Try to answer those questions instead. Prompting for the given is a simple fprintf to tell what the type of equation we're solving is, and asking for a, b, and c. Calculating the discriminant is delta equals b squared minus 4ac. Now, I've already coded the bottom, which are all my equations. At one point, I will have to code all my equations regardless. But now is the time to tell MATLAB to skip some of these, depending on the delta sign. So the first keyword is always going to be if. And notice how it appeared in blue. Let's do delta is positive. This is a relational operator, the greater than symbol. It checks the relationship between delta and 0. Is it greater than, less than, or equal to? We are checking greater than. Now if it is positive, these are the 2 equations that are involved. What's the next keyword? Else if. If we have a second condition to check, else if will be the next keyword. Let's check delta is equal to 0. In this case, we need this equation to be there. So I will move it up. And then the last 2 parts is the real and imaginary part of the solution. Now on this one, which keyword should I use? There is no other possibility. It's either positive, equal to 0, but mathematically there's nothing else that it can be besides negative. So in this case, I will use the default else. And notice how I'm not typing delta negative. That's the only thing it can be. If you want, you can write a comment. The last keyword that we need is the END. Now everything's messed up as far as indentation and spacing, so I will clean that up. Thankfully, MATLAB has a automatic indent option. Control A to select all, Control I to indent. These conventions are throughout every language. We indent the body of an if statement. Now right now, if I run the code, which equations will happen? Will they all go? Will MATLAB actually read all of them? No. MATLAB will first check if the delta is positive. If it is true, it will execute these 2 lines, and here's the important part, skip to the END. So MATLAB will ignore all the lines all the way up to here. But then it does not stop. If I put an fprintf bye-bye, for example, MATLAB will continue and print it. Let's try To make sure that the delta is positive, I will do a huge b coefficient. Let's do 1 for A, B, and C. So as you notice, x1 and x2 did show up. But how come x and real part, imaginary part did not show up? They do not have semicolons. Well, MATLAB went through the body of the if statement and skipped to the END, then continued peacefully all the way up to the last line of my file. If I try to do a negative, so let's do a tiny b and a huge A and C. Notice how MATLAB did not print x1 and x2 because delta was not positive. Delta was definitely not 0, so MATLAB skipped this line and went directly to the ELSE. It did print real part, imaginary part, and then continued with the code with fprintf. So this is automatic. A lot of students ask, how does MATLAB know? MATLAB just knows because of the keyword. It knows to skip between the keyword whether a condition is true or false. To finish this code, you could definitely print fprintf statements to display nicely the results. In that case, you would have to put an fprintf within each block of code. Notice here I decided to check positive first, but let me show you another option. Here I decided to check equality first, then positive, and in that case the else was left for the negative. Why not? There is no actual order on this problem since all three conditions are very independent: negative, 0, or positive. In the next example, we'll see that not all keywords are necessary. Only the if and the END are required. Knowing a man's mass, the acceleration and direction of the helicopter, calculate the tension on the cable at the point where the man is hanging. So, our givens are the mass of the man, the acceleration, and the direction, up or down. We are asked to find the tension in the cable. As far as equation, there is only one, Newton's second law. But if we don't assume different things, this will be very complicated. So we will assume that the cable itself has no mass, and we will neglect air friction as well. After a little bit of physics and equations, we end up with two possibilities. If we're going up, gravity is added to the acceleration. If we're going down, the acceleration is subtracted from gravity. So again, we have two equations. The algorithm is once again straightforward. Prompt for the given, we have three givens, and calculate the tension on the cable. Notice again, I don't have a comment, a useless comment, saying if statement. The givens are asked as mass and acceleration will be numerical values, but the direction will do letters. If statements can handle letters and string inputs as well. I've gone ahead and calculated the tension for the up direction. And I'm going to show you that we do not need an if-else, just like the quadratic equation. Let's assume that he says up direction. In that case, we're perfect. It calculates with adding the acceleration and gravity, and it displays the result. If it's going down, the only thing we would like is that acceleration becomes negative. So if I enter 20, I would like a negative 20 here. So that's the only little option we want to code. Change acceleration if down. So if direction is down, is equal to down. Now here, one common mistake is just to do D. But D is not a variable. Remember that everything is in black here, meaning a location in memory that has a value inside. Mass will have maybe a number, acceleration another number, direction will have a letter. We don't want a variable called D that has something inside. We want the actual letter D. So always remember to put the quotes to tell MATLAB it's a string. If the direction is down, we want to change the acceleration to its opposite. This is the same as doing -1 times, which is absolutely useless. So the acceleration is equal to minus the acceleration. So by the time MATLAB reaches the actual equation, this does not change, for sure, but the content of acceleration has the minus sign built in. So in this case, you do not need an else. If it's up, MATLAB will skip the if statement completely. But if it's down, MATLAB will make a minute change to the acceleration before reaching the tension. 55 kilogram, 20 acceleration, going up. We end up with our 1600. 55 kilogram, 20, but going down, we end up with negative 560. This means that the chord is not in tension, it's going downward. Planning when problem solving. A lot of students ask us, how do I know where to start? Where do I even start looking at these conditions? Here are several tips. Identify how many conditions. For the quadratic equations, we had 3. For the helicopter, we had 2, and by planning a little bit differently, we brought it down to 1. Identify priorities. Maybe there is a condition that will happen a lot more often than the others. I would put that one first to save MATLAB time when it runs. Identify which condition should be the default else. Try to find the condition that's hard to write down using relational operators. Identify if there's an order. One condition can eliminate other options, and we're going to see that right now. Knowing the Mach number at which an object is flying, identify which regime it fits under. So you have subsonic, transonic, supersonic, hypersonic, high hypersonic, and re-entry speed. These all have their boundaries. We are given the Mach number, but we need to find the regime. My first question is, how many conditions do you see? Which condition should be the default? What order should the conditions be in? Notice I've scrambled all of them. Which one should come first? Does it matter? There are 6 conditions right here. There are 2 options for the default. So how do we tell MATLAB we want from negative infinity to 0.8 and from 25 to positive infinity? Those are 2 options. There is definitely an order to respect to make your coding easier. The beginning of the code is very easy. Prompt for the Mach number and indicate the regime. This is where we want MATLAB to skip to the right sentence. Is it supersonic, hypersonic, or whatever? As far as order is concerned, my best advice is to be chronological. There is definitely a chronological aspect to the 0.8, 1.2, 5, 10, 25, and above. Start with one of the extremities. For example, if the Mach is less than 0.8. Then go step by step. Else if is the next keyword. Should I rewrite this one? No. This is a major key point of if statement. If the Mach is less than 0.8, MATLAB will execute this line. Else if. Just think about that keyword. What does it mean? Else? Well, else what? Else. It tells you that MATLAB knows that this condition was false. Mach was not less than 0.8. Well, right there, that's exactly this sentence. Mach is not less than 0.8, which means it has to be greater than. This is implied. There is an order so that MATLAB eliminates pieces by pieces. So right here where my cursor is, we already know that Mach is greater than or equal to 0.8. So the next boundary that we want to check is 1.2. Fprintf, and then we'll figure out which one to put. Else if Mach is less than 5. Else if Mach is less than 10. Else if Mach is less than 25. And then the last one is my default. Everything that is above 25. By planning carefully chronologically, it really is that simple. Write each boundary that you have, and that's it. You could have gone another option to start by the 25. If you decide to go chronologically, but from the top, 25 is the top, 10 is the next one, 5, 1.2, 0.8, which means that the default is everything between 0.8 and negative infinity. This is where, if you want to, you can definitely introduce error message. Maybe I did enter a negative Mach, which would make no sense at all. Why not? You can plan, but my biggest advice is to stay chronological to make coding a lot easier. Here are the key points. In any programming language, conditional statement will be used to skip parts of a code. If and switch are possible, this tutorial introduced if. If requires the END keyword, but that's it. Notice for the helicopter going up and down, we did not use else if, we did not put an empty else statement, we just omitted those two keywords. The only time you use else if and else is if your logic requires it. Else is, however, always last and requires no condition on its line. Plan before you code. By analyzing and setting up every little condition, you might not code that much. The best practice, if you've noticed, is there is no semicolon on any lines that starts with a blue keyword.